All right, we are covering part 2 here for the ambiguous case. We are going to tackle the same problems in the previous video where we used law of sines, but this time we will use law of cosines. So take notes. 7.3, the ambiguous case, part 2, law of cosines. So again, it's when you have this side-side angle, and now we're going to look at law of cosines. Whichever one you use is fine. If you have a preference, that is fine. Sometimes it may not be possible to use one or the other. Okay, so the three cases. So the possibilities are the same with law of sines. We could have the zero triangle case. We could have the one triangle case. Or we could have the two triangle case. Okay. And we will look at each of these using the same problems we did in the previous video. Okay, so the zero triangle case. Okay, so let's take a look at this example here. Suppose that you had to solve triangle ABC. If A equals 2, B equals 6, and A equals 30 degrees. Okay, so again, I like to draw my triangle A, B, C. A is 30 degrees. Okay, little a is 2, little b is 6. Okay, so if we are trying to solve the triangle, let's take a look and see what we have so far. Okay, so we have 30 degrees here, 6 here, and no, 6 here, and 2 here. Okay, so again, we already know this is the zero triangle case, but when you do the problems, you won't know which one you're going to get. But just know that if you are solving the triangle and there are two cases, the only ones that will have two values are these here that are missing. Anything that is given will only have one value. Okay. All right. So let's take a look. All right. So I have A's. I'm using law of cosines. So I'm using the one that has cosine A, which means I'm going to be using this one. A squared equals B squared plus C squared minus 2BC times cosine A. I am using this one because I have angle A. And I have A and I have B, which means I will be using this one to solve for C. Okay, so here I am solving for little c. All right, so A is 2. So 2 squared equals 6 squared plus C squared, we don't know, minus 2 times 6 times C, we don't know, cosine of 30 degrees. Okay. So this is 4 equals 36 plus C squared minus 12C. Cosine 30 is square root 3 over 2. Okay. I'm going to go ahead and cross cancel the 2 and the 12. Okay. So I get 4 equals 36 plus C squared minus 6 square root 3C. Okay, so we have a quadratic here. So let's set it equal to 0, subtract 4 on both sides. Okay, so we set quadratics equal to 0. We get 32 plus c squared minus 6 square root 3c. All right, and I am going to go ahead and write this in descending order. Okay, so here, don't think this is factorable. Okay, so this isn't factorable, so let's use quadratic formula. Quadratic formula to solve. Okay. All right. So here, quadratic formula: a is 1, b is negative 6 square root 3, and c is 32. And if you remember the quadratic formula, x equals negative b plus minus the square root b squared minus 4ac all over 2a. Okay. So this is what we are going to use. And we will plug those values, a, b, and c, in here. So I got these values from here. Coefficient a is 1. Coefficient b is negative 6 square root 3. Coefficient c is 32. Okay, so then we get x equals negative 6 square root 3 plus minus the square root negative 6 square root of 3 squared minus 4 times a times c all over 2 times 1. Okay. All right. So then working this all out, we get positive 6 square root 3 plus or minus square root of, what is that going to be? 36 times 3, 108, minus 4 times 32. That is 128 all over 2. Okay, so then we get x equals 6 square root 3 plus minus the square root of, what is this? Negative 20. Negative 20 all over 2. Okay, so this ends up being negative, which is imaginary. So this is where our, no solution arises. Okay, so no solution or no triangle. Okay, because this is not possible over the reals. Okay, and I guess I really should, this is a quadratic formula, but we were really solving for c here. So let me change this. This really should be c equals. And so c cannot be imaginary, so we have no triangle here. Okay, so that took a little bit of work, but not impossible, just kind of a pain. All right, let's take a look at the one triangle case. One triangle. Okay, so let's take a look at this here. Let's solve triangle ABC if C equals to 35.4 degrees, A equals 205 feet, and C equals 314 feet. Okay. All right, so we have triangle ABC. C is 35.4. A is 205. C is 314. Okay, so A, B, C. Little a, little b, little c. I'm leaving space here in case there is a second triangle, but we already know there's only one. Okay. C is 35.4. A is 205. Oops, wrong place. 314. And then angle C is 35.4. Okay, so again, the only places where you would have two different values is here, the ones that are missing. That's if you have a second triangle. Okay, these are always going to be constant because they are given. Okay, so let's look for, in this case, I have angle C and little c, so I'm going to be using this. C squared equals a squared plus b squared minus 2ab cosine c. Okay, so I'm using this one because I know angle C and I know little c. Okay, so this is what I'm using. Let's see what I'm solving for. I have angle C and little c. I have little a, so I'm solving for b. Okay, so I'm using this to solve for b. All right, so little c is 314. Little a is 205. B we don't know. 2 times 205 times b times cosine c is 35.4 degrees. Okay. All right, so big numbers. Don't be afraid of big numbers. So punch this into your calculator and you should get this. And then this and B, we don't know. And then when you punch all of this in, you should get 334.202B. All right, another quadratic. Okay, so another quadratic, set this equal to 0. If you set this equal to 0 and put it in descending order, you'll end up with 0 equals b squared minus 334.202b minus 56571. Okay, so again, quadratic, so not factorable. So we're going to use the quadratic formula. So use the quadratic formula here to solve for b. And a is 1. B is negative 334.202. C equals 56,571. Okay, let's go ahead and punch that in. So little b equals negative plus or minus square root b squared minus 4 times a times c all over 2a. Okay, and then we get positive and then when you punch all of this in to your calculator and then take the square root, you will get 581.356 all over 2. Okay, and so here when we do the addition portion of it, okay, so we end up with getting 2 answers, right? When we do the addition, 334.202 plus 581.356 divided by 2, you will get 458 when we round off, okay, because we need 3 significant digits. So we get this one. When we do subtraction, then we end up with roughly negative 123. Okay, so this is solving for b. B is a side. Little b is a side. This is not possible. So we only have this case here. Okay, So let me go ahead and fill in my triangle up here. So this here is 458. Okay. And then here we can solve for A and for B. Okay. So we can use law of sines to solve for A and B here. Okay. Let's go ahead and let's solve for A. All right, I'm going to do it over here so that we don't have to scroll down all the way. All right, so I'm going to solve for A over here. So I'm going to use sine A over 205 equals sine 35.4 over 314. Okay, so when I solve for A is going to equal sine inverse of 205 times sine 35.4 over 314. Okay, because I have to multiply both sides by 205. And then after that, I have to take the sine inverse. Okay. All right, so when I do this, I get 22.22 degrees, or roughly 22.2. Okay, 3 significant digits here. So 22.2. All right, and let's check if we have a second angle A, then it would be the one that is 180 degrees minus 22.2 degrees, because it would have a reference, it would be in quadrant 2 with a reference angle 22.2 degrees. And here, this would give us 157.8. And then we check if it's possible. Okay, so check if it's possible. Well, A plus B plus C, so 157.8 plus B. Do we even know B? No. But we know A is 157.8, B, and then C is 35.4. So plus B plus 35.4. Are we able to get 180 here? No, because 157 plus 35 is more than 180. There's no room for B. So this is not possible. Okay, so not possible. So we do only have the one triangle case. So then here I can find angle B. I'll just do it up here. Angle B, there's only one, and we can do 180 minus 22.2 minus 35.4, because these three should add up to 180, right? All right, so angle B equals 122.4 degrees. Okay, so angle B is 122.4 degrees. I should have done this one in purple too. 22.2. Okay. All right. So like over here, because we didn't get two B's, that's kind of a clue that you won't have two, but really it starts to show here in the angles. It just really solidifies the fact that two triangles is not possible. Okay. All right. So once you find another angle, we started off not finding an angle, but looking for a side, a missing side. But as soon as you are able to find that one angle, check to see if you can get a second angle by doing 180 minus the one you found. Okay, because remember, it's to find the second one, it will be in the quadrant 2 with the same reference angle as whatever the angle that you found is. Okay. All right. Let's take a look at the two triangle case. You still with me? All right. Okay, so, and this is just the last one. Okay, so two triangles. Two triangles. So here, so take a look at this one. Solve triangle ABC if A equals 54, B equals 62, and angle A equals 40. Okay, so let's go ahead and draw that. So there's A, B, C, 40 degrees here, 54 here, 62 here. Okay, and A, B, C, and little a, little b, little c. Okay, this one is 40, this is 54, this is 62. So here, these three will be the ones that have some other value. Okay, A, B, C. I'm just getting this ready. You won't know to get it ready until you check to see if two triangles is possible, but you already know because I told you I'm going to do a two triangle example. Okay, so here these will also still be the same. Whatever is given stays that. It doesn't change. All right. Okay, so let's go ahead and find this missing side here since we have. Okay, so here, let's just set this up. We already know we're going to use law of cosines, and we have angle 40 and little a, angle A and little a. Okay, so that means that we are going to be using this version of law of cosines. Okay, so we're going to be using this one, right? Because we have cosine A, and that's what we're going to use. Okay, it's getting late. All right. So we have angle A, we have little a, we have little b. So that means we will be using this to solve for little c. Okay. All right. So A is 54. Little b is 62. Little c we don't know. Little b is 62. C, and then cosine 40. Okay, and again, some big numbers here. 2,916 equals 3,844 plus c squared minus, punching that all in, we end up with 94.99 c. Okay, so again, we have a quadratic that does not look factorable. So let's go ahead and set this equal to 0 and put this in descending order. Subtracting 2,916 on both sides, we get 928. And then here, so this is not factorable, so let's go ahead and use quadratic formula. I get the feeling some of you guys are already leaning towards using law of sines instead of law of cosines. And then here, using quadratic formula, A is 1, B is negative 94.99, and C is 928. Okay, and we are solving for C. All right, so little c equals negative b plus minus the square root b squared minus 4ac all over 2a. All right, so when you punch this all in, you get 94.99 plus or minus the square root of, actually, let's do the square root as well. So punching this into your calculator and taking the square root, we end up with 72.877 all over 2. And so we will do, when we add, okay, so when we add 94.99 plus 72.877 and divide by 2, we end up with roughly 83.9335. We will, how many significant digits are we dealing with here? Okay, so we will take 84. Okay, when we do the subtraction here, then we get roughly 11. We don't get anything negative, so we get 11.0565. So we will take 11. Okay. All right, so we have two C values here. Okay, so the first one we get is, we said 84. And the other one that we get, oh, here, let me do that one in purple. Okay, so we get 84 for the first one, and we get 11 for the other triangle. Okay, and so now you just go ahead and solve each of these triangles. And at this point now, you can use law of sines, right? So like here, we can solve for B using law of sines. Okay, and then same thing here, use law of sines to solve for B. Okay, so let's see. Let me go over here. Okay, all right, so let's go ahead and we'll break this up into two sides now. So this one is from triangle 1, and this side will be for triangle 2. Okay, so so let's go ahead and solve for let's go ahead and solve for angle C. You could continue to use law of cosines. But like I said, I think some of you guys are leaning towards law of sines. You can do law of sines, but since this section really is about using law of cosines, I'm going to use law of cosines here. Okay, so I'm going to go ahead and find angle C. Okay, angle C. And so here, I'm going to be using this formula. C squared equals A squared plus B squared minus 2AB cosine C. Okay, and it's this angle here that I'm looking for. Okay, so we have 84 squared, which equals 54 squared plus 62 squared minus 2 times 54 times 62 cosine C. Okay, and once you work this all out, you will get 296 over negative 6,696 cosine C. So to solve for C here, you will then need to take the cosine inverse. Okay, so if we take the cosine inverse of this, then we will solve for C. Okay. And so it turns out it is roughly 92.534 degrees. Okay. And over here, let's see. Okay, so two significant digits. So we will go with, is that 93? Okay, so let's go ahead and fill this in 93 degrees over here. Okay, and then you can get angle B because these three should add up to 180. Okay, so angle B should equal to 180 minus 40 minus 95, and that comes out to be 47. Okay. And then same thing here. So then now let's go ahead and solve for C. Again, you can use law of sines or law of cosines at this point. I will go ahead and continue using law of cosines, just like I did over here. But this is angle C, the second one. Okay, so again, I'm using C squared equals A squared plus B squared minus 2AB cosine C. Okay, and then over here, but here when I'm solving for this angle, I have to use the numbers that I have here. So here, lowercase c is 11. Okay. So this one here becomes 11 squared. 11 squared equals 54 squared plus 62 squared minus 2 times 54 times 62 cosine C. Okay. And then I'll go ahead and skip some of those steps there. Solve for cosine C here. Get everything to the other side. And you will end up with negative 6,639 over negative 6,696. And this is cosine C. And solving for C, we will now take the cosine inverse of this side. Double negative becomes positive. And that will give us C. And so this here gives us roughly C equals 7.481. And again, I believe we need just the one. Okay, so up here, C is 7 degrees. Okay, and then now we can find angle B. So angle B in this triangle is going to be 180 minus 40 minus 7, and that will give us 133 degrees. Okay, so that's how you can do the ambiguous case where you have two triangles. You should be able to get two answers here when you do your quadratic formula, unlike the previous case where you had only one triangle because you ended up here with a negative result and your sides cannot be negative. But here in the two triangle case, you'll be able to get two answers. Okay. All right. If you have any questions, make sure you email me or you text me, or use the Ask Your Instructor function on WebAssign.